I'll try my best to explain the difference between population and sample statistics clearly, so you have a much better idea of them after you watch this video. This is my country, South Korea. It has a population of 51 million. Say we want to know the average IQ of Koreans. So we will conduct surveys. Survey A was done with 100 people in that island. Is this a population survey or a sample survey? This is a sample survey because we are only surveying few people. Survey B was done with 10,000 people in that green region. So the scale went up. Is this a population survey or still a sample survey? Still a sample survey because it's still a small region. This time, survey C was done, and it was done with 10 million people. This is a very large-scale survey. So is this now a population survey or still a sample survey? This might be surprising, but 10 million people being surveyed is still a sample survey because that wasn't the entire population. Now, survey D covered almost the entire land, as you can see. 45 million people have participated in the survey. But unfortunately, this is still a sample survey. Finally, our last survey. Survey E was done with 51 million people. Every single person living in this country, even those who live in the island, participated in the survey. Not a single person exempted. This is a population survey. So you see, a population survey is almost unrealistic on this big scale. So does that mean a population survey is impossible? It is possible. Imagine there's a classroom with 12 students and we want to know the average IQ. If we survey all 12 people, that is the population survey. So depending on topics, it could be a population survey. In this case, the topic was about just one classroom. Okay, so we clarified the terminologies. Now let's talk about the standard deviations. I explained about the standard deviation in the other video, so I'll jump right into this. You probably learned that we divide by n for the population, but divide by n minus 1 for the sample. The population one may look okay, but the n minus 1 from the sample looks odd. Why can't it be just n, just like population? There are two reasons to this. Let's think about this mathematically. Say we have 1 over x, where x is some number. As x value becomes larger and larger, this whole fraction becomes smaller and smaller. Agree? And similarly, as x value becomes smaller and smaller, this whole fraction becomes larger and larger. So we have to think this oppositely when changing the denominator, right? Even high school students know about this. Now, here we have 1 over x and 1 over x minus 1. Clearly, x minus 1 should be a smaller number than x. So which fraction should be greater? Of course, the right one. So this means the n minus 1 expression should give a larger standard deviation than the original standard deviation as well. I'm just calling the population version, which has just n, the original. Anyway, now.
왜 리미야? 아빠 뭐 얘기하는 거 같아? 누구랑? 아니야.
Anyway, now, what does a larger standard deviation mean? I did mention this in the other video. Higher uncertainty, right? Which means we're less sure about something. This is the point. If we have a sample data instead of a population data, we should always be less sure about its statistics, at least less than the population statistics. I have an example here. This is a population statistic which shows the average height of 100 people. The average height was 170 centimeter with a standard deviation of 20 centimeter. Okay, we could review the standard deviation. 20 centimeter means within 170 plus minus 20 centimeter, there are 68 people. And 95 people within plus minus 40 centimeters. And all 100 people within plus minus 60 centimeters. That's what the standard deviation tells us, right? Now, let's say you survey 20 random people only to estimate the average height of the entire population, which is 100 people. The average height of 20 people you surveyed was found to be 149.5 centimeters, let's say. But then just by coincidence, your standard deviation for 20 people happened to be 20 centimeters as well. So what does this mean? First of all, this means you're 68% confident to say that the average height of the entire population should be somewhere in between 129.5 and 169.5 centimeters, which is the plus minus 20 centimeters from the average height that you got. And you're 95% confident to say that the average height of the entire population should be somewhere in between 109.5 centimeter and 189.5 centimeters, which is the plus minus 40 centimeters. But wait, you only surveyed 20 people. And how can you be as confident as if you surveyed the entire population? I mean, how can you be as sure as surveying 100 people if you haven't surveyed 80 people yet? This is the situation that you want to avoid. You might be overconfident without noticing that you're making a wrong conclusion. Let's be more skeptical. I mean, let's be less sure about our guess. If we subtract n by 1, of course the standard deviation will slightly go up. Because the denominator is now a smaller number, right? So we are less confident than in the population statistics. Yes, this is pretty much one of the two reasons. Okay, but why negative 1? We could do minus 0.1, no? Well, n is a number of data, right? It's an integer. The smallest integer to be considered is 1. And you don't want to subtract by a too large number. Okay, so now, some people could ask, what if I got as low as the population standard deviation even after n minus 1? Well, then, good for you. End of the story. What can we do? Like, you still got an accurate result even after n minus 1. So that just means your estimation was pretty accurate, and you're just allowed to feel certain about it. But to be honest, this won't really happen in real life. Let me explain you what I mean by that. Someone might also ask, what if the number that I got is even lower than the population standard deviation, even after n minus 1? This has other reasons. See, in nature, sample standard deviation should not be lower than population standard deviation. Because lower standard deviation means higher accuracy. How can a sample statistic be more accurate than a population statistic? And yet, this does happen sometimes, but not in the professional field. If you found out that you got a lower standard deviation, then you should doubt about your survey method, because that's not a natural result. There's a high possibility that your method was biased. For example, you might have focused more on females than males. Or maybe the sample wasn't enough for the statistics. So this was not even proper statistics in the first place. So let's recap. Most of the large-scale surveys that are done in real life are sample surveys. It's very hard to conduct a population survey on a large scale, and you understand why. And also, n-1 is like a safety device for an estimation with samples. It makes us less confident about the results we obtain from sample statistics. Okay, so what's the second reason? This is even more mathematical. Say you surveyed just one random person and tried to estimate the average height of the entire population, which is ridiculous, I know. But let's say we attempted to do that. You would later want to say that I think the average height of the entire population is in between something and something, right? But wait, you had only one sample. Can you even think of any ranges? Probably not, right? It's impossible to even define anything at the moment. And in fact, if we use the n-1 expression, this will become clear. As there's only one sample, it's gonna be just 190 minus 190 over 1 minus 1. This is 0 over 0, which means it's undefined in mathematics. And this makes sense. It shouldn't be even definable. Like, we couldn't come up with any range before, you remember? So what if we used n instead of n-1, just like the population statistics? Then this will be 190 minus 190 over 1, which will give 0. A standard deviation of 0 means no uncertainty. So this means we are fully confident? But we know that this was a sample survey. How can you be 100% confident that the average height of the entire population is 190 centimeters? This doesn't make sense. So even mathematically, n-1 makes much more sense. Okay, but then why the population survey uses n, not n-1? Is this kind of circumstance okay in population statistics? Okay, stop for a second and think about this. Population survey is when you know that you have a complete data. If this was a population survey, this automatically means that there's really just one person living in there. So with just n, 190 minus 190 over 1 gives 0. So 100% certain? Yeah, why not? That's literally the only person who's there. The average height of the entire population is that person's height. So for population statistics, we don't need n-1. N still works, so we can just keep n. This was why they're different. Each of them works suitably for its own environment.